All right, so Emma, this is 2019 question 6. Emma is moving to a large city and is investigating typical monthly rental payments prices of available one-bedroom apartments. She obtained a random sample of rental prices for 50 one-bedroom apartments taken from a website where people voluntarily list available apartments. Describe the population for which it is appropriate for Emma to generalize the results from her sample. So this is really key. We can only generalize to the population from which our sample was drawn. And basically, our initial responses go, you know what? Was this large city? Well, yes, sort of. But it's actually much more precise than that. Emma's results can be generalized to one-bedroom apartment rental prices listed on the website. All right? This is the key phrase. These are the ones that she used, the ones listed on the website. And technically, it's at the time of the sample. But if we have it listed on the website, we should be good. All right? The next part says the distribution of 50 rental prices of available apartments is shown in the following histogram. So we have this histogram, and when I look at this histogram, the first thing I look at and go, you know what? I have a bunch grouped over here, but it's also stretched out to the right. So without even doing much anything other than just looking at the picture, it's like, oh, we got a bunch here, but we're stretched to the right. So it's not perfect, but I'm going to say it's kind of skewed to the right because it's stretched to the right. We have upper values here. And if it is skewed to the right, then we would expect our mean to be above our median because the mean is impacted by the extreme values. So it says Emma wants to estimate the typical rental price of a one-bedroom apartment in the city based on the distribution shown. What is the disadvantage of using the mean? Because a lot of times we just, hey, let's take the average. What's the average price? Well, when we look at the distribution, we know it's skewed. So rather than the median as an estimate of the typical rental price. So because the distribution of rental prices is not symmetric, and if it is symmetric, then using the mean is a really good choice. But because it's not symmetric and skewed to the right, the men will tend to overestimate typical rental prices due to a few prices being much higher than is usual. The median is not impacted by extreme values and would provide a more accurate representation of typical rental prices. Now, I'm going to ask you to be really careful here. There might be some other word besides typical. To be honest, I was having trouble coming up with it. I want to say the normal price. Well, I'm afraid to use normal because we're talking about statistics. I don't want to say different than the average price because average is the mean and we're actually interested in the median. So I need something that says the usual, the typical, all right? So I chose the word typical, but there might be another word besides typical, but we're looking for what is the typical price, what would we generally expect to happen, okay? But we don't want to use average because that is the word for mean, and we don't want to use the normal price because normal is a type of distribution and this one is not. So this is something to be careful of. And by the way, if you have questions, post them in the chat and I will try to get to them, or Mrs. Lamb will, one of the two of us, and we may or may not answer the question out loud, but we will do our best to get to those questions. All right. Moving on, part C. Instead of using the sample median as the point estimate, another word, and when I say a point estimate, they just mean a single value. So instead of using a single value for the population median, Emma wants to use an interval estimate. So she wants to create a confidence interval. And you know, that's kind of curious because I don't think we covered, matter of fact, I know we didn't cover how to create confidence intervals for a median. So they're going to assume that you use the same method that you use for a mean, but they're going to use a median. However, computing an interval estimate requires knowing the sampling distribution of the sample median for samples of size 50. Emma has 1 point, her sample median in that sampling distribution. Using information about rental prices that are available on the website, describe how someone could develop a theoretical sampling distribution of the sample median for sample means of size 50. Well, I'm going to digress for just a moment. When we talk about the sample distribution of the sampling means, when we talk about the distribution of the sample means, we know that it becomes normal for sample sizes 30 and larger, but the sampling distribution is really a listing of all possible combinations. Well, that's what it is here as well. It's a listing of all possible combinations, and in this case of size 50, not of the means though, of the medians. So pretty short answer, but actually a very difficult one to actually conceptually get. You would need to collect all possible combinations of samples of size 50 for 1-bedroom apartments listed on the website and compute the median for each of the samples. So a sampling distribution is a listing of all possible combinations of that size. Whether that's the sample means, which we'll usually talk about, the sample mean is the listing of all possible means for that size, where here it's all possible medians. Okay, and be careful that in this problem that you are talking about the median. Do not switch. All right, don't switch because you know one and not the other. All right. Okay. I'll pause for just a moment. I'm going to pause this.
Put it back on for a few seconds.
So Emma ran the Bootstrap process. Oh, excuse me, I'm skipped ahead, and I should not have. So because Emma does not have the resources to develop the theoretical sampling distribution, she estimates the sampling distribution of the sample median using a process called bootstrapping. In the bootstrapping process, a computer program performs the following steps. Takes a random sample, which she did, with replacement of size 50 from the original sample. Calculate and record the median of the sample. Repeat the process to obtain a total of 15,000 medians. Now this is kind of explain really what's happening here. They take a random sample of 50 and they have a random sample, and but they put in replacement. Otherwise, every single median would be the same. But by putting it back in, each one could be different because I can draw the same number multiple times. All right. So we could end up with a whole bunch of different samples. We could actually end up with a sample that had the same value theoretically. Anyway, so they repeat this process for 15,000 times. So here we go. We have this graph. So Emma ran the bootstrapping process, and the following frequency table is what they came up with. And basically, please remember a frequency. They ended up with a median of 2,345 one time. They ended up 2,390 13 times, 2,500 1899 times, et cetera, et cetera, et cetera. Those are how many times they occurred. So the bootstrap distribution provides an approximation of the sampling distribution of the sample median. A confidence interval for the median can be constructed using a percentage of the values in the middle of the bootstrap distribution. Find the percentage of bootstrap medians in the table that are equal to or between the values found. I skipped ahead. I'm not sure what happened to part D. Hold on a second, excuse me. So use the frequency table to find the following, the value of the 5th percentile. Well, 5% times 15,000 equals 750. 5% of 15,000 is 750. And then I start adding. 1 plus 13 is 14. Then I add 18. And I keep adding until I get a value that includes 750. Okay? Well, that happens right here. And you're like, well, wait a second. That goes way over 750. Yes, it does. But when I add all these values up to here, I don't get to it. It's not till I get to 2,500. It's not till I get to 2,500 that 750 is actually included. So 750 is included in this value. So my, in this case, my 5th percentile occurs at 2,500. All right, so that's my 750th, and I said mean, that's incorrect. That should say median. All right, then it also asks for the 95th. Well, now I'm just going to take 95% times 15,000 and I get 14,250. And so I'm going to go back and I'm just going to have to keep adding and adding and adding and adding all these frequencies. And please don't forget the middle column of frequencies. And it turns out that when I get to right here at 2,950, I now have my 95th percentile. So my 95th percentile or my 95th median occurs at 2,950. So 5th percentile and 95th. Just a second. So the question was, hey, instead of adding all those up, could I have worked backwards? And the answer is yes, you can. Absolutely. Be careful doing it, but you absolutely can. And you would find out once again that if you did it correctly, you would end up here. And they're saying, hey, can I add these up until I get to 750? And that'll work. All right, absolutely it does work. Very fair and very good way to do it. Part E, find the percentage of bootstrap medians in the table that are equal to or between the values found in part D. And they're like, wait a second. They just want me to find how many times it occurred between 2,500 and 2,950? And the answer is yes. That's all they want me to do. So I add up all those values, and remember, we're starting at 1,899 plus 2 plus 945 plus 1,673 plus 1 plus 171 all the way up to 2,950. And when I add up all those values, and that's what I showed here, I added them all up. I divided by 15,000. Well, I added them up. I got 14,404. I divided by 15,000, and I got 96%. All right. So I ended up getting 96%. And then part F is actually fairly straightforward at this point. Use your values from D and E to construct and interpret a confidence interval for the median rental price. Well, what was our lower bound? 2,500. What was our upper bound? 2,950. What percent did we capture? 96%. So essentially, we created a 96% confidence interval, and they're just asking us for our conclusion. So we are 96% confident that the true population median price of 1-bedroom apartments advertised on the website lies within the interval $2,500 to $2,950. Please note, I don't need to go ahead and write what my definition is, but my definition of my proportion would have been the median price of 1-bedroom apartments advertised on the website. And that's basically what I filled in there. Okay, I'll give you a moment or two to copy that down, and then Ms. Lamb will come in with some comments on how to score this. All right. Go ahead.
All right. Okay, guys, this question is broken into 6 parts. So I need you guys to focus in on part A and B right now. That is section 1. For this section, there are 3 main components that they're looking for. Part A is a component all on its own. So if you generalize correctly, you get an E for part A. For part B, they're looking for 2 main components. So they're looking for that the mean is going to be an overestimate because of the skewness. So we always talk about why, we know things, right? So that skewness is kind of like the why. So that together makes an E. And then if you talk about the median being better because extreme values don't affect it, again, that's kind of like the why we like the median better. That's your third E. So there are 3 main components. If you get all 3 E's, that's an E for section 1. If you got 2 out of the 3, that's a partial. Okay, so think of it as points. So we're looking for 3 points, full points. You can label this section, part A and B, as an E for essentially correct or a P as in partially correct. If you didn't, if you only got 1 out of the 3, that's an I. All right, part C is a component all in itself. So if you describe that one correctly, and what we're looking for on part C is that we describe that we need to collect all possible combinations. That's the key component there. And that what we're doing is we're computing the medians. If you have both of those 2 parts on part C, you can score yourself an E for this section. If you well-defined one of those parts, that's a partial. If you missed both those parts, it's an I. So label part C as either an I, a P, or an E. All right, for the next section, your third section that they're looking at is part D and E is together. So on part D, if you correctly calculated your percentiles with correct work shown, that's one of the key components. They did have some things that they considered plausible. So I guess this would be for if you counted or added incorrectly within your frequency table. They gave a little bit of a margin of error on what your numbers could plausibly be for partial credit. The other key component that they're looking for is that you calculated the 96% correctly with correct work shown. Again, there's a little bit leeway for error for counting errors here. If you accidentally skipped one of the frequencies or things like that, you could have gotten partial credit. So if you got both of those 2 components, you get to score yourself an E for section 3. Section 4 is interpretation of your confidence interval. They're looking for 3 parts. The 3 parts they're looking for is that you identified correctly what kind of confidence interval we have. They were accepting 2 answers, one based on part E, your 96%. If you calculated incorrectly here, but used it here, that does not count as a secondary error. But they also accepted something that is at least a 90% confidence interval. From part D, because we took the top 5% or the bottom 5%, that would create at least a 90% confidence interval. So they accepted your sentence stem. If you started off as we are at least 90% confident, they would have accepted that as completely right. So that's one part. The other parts that they're looking for here is that you are talking about the true population median. Make sure you don't go on autopilot and revert back to mean. And that you have good endpoints. And these endpoints should match from previous work. So if you got all 3 of those parts correct, then you get to grade yourself an E. If you got 2 out of those 3 parts, that's a partial. And remember, do not count these as errors if you're basing it on your work from D and E. They don't count a second time against you. So there were 4 main parts to this question, and each part is a point. So for every part E you got, that's 1 point. Every part that you scored yourself a P, that's half a point. So now you can add up your points and see what you would have scored on this question 6.
I'm going to pause recording.
Do we have questions?